The textbook for this class includes several examples as well as what it refers to as matched problems. So the examples in the book are already completed. There's a written description of how to walk through those step by step. And then if you open the e-text, there are also links to open up video demonstrations of how to work through each of those examples. So since the examples in the book are already worked out two different ways, either by reading through them, watching those videos, instead what we're going to do is work through each of the matched problems. So these exercises are designed for you as the reader to work through them, understand them. So what I would encourage you to do is try each of these problems on your own first, and then if you're not coming up with the same answers that the book is coming up with, use this as a way to check those solutions. So let's start off with match problem number 5. The first 4 match problems are all graphing problems, identifying limits and behavior of graphs of functions by reading graphs. So we're going to skip those and jump straight into the algebraic problems. This first example, we're going to work out a little more long form than we will typically have to, just to see how some of these properties are used. Let me make one correction here before we get started. Instead of the limit as x approaches 3, that's a typo on my part, that should actually be the limit as x approaches -2. So the very first thing we're going to do is use the properties of limits that we established to break this up, since what we have is the sum of a function x squared and 5x. We can take that limit and apply it to each of those functions individually. So we can rewrite this as the limit as x approaches -2 of x squared plus the limit as x approaches -2 of 5x. So properties of limits let us break up the limit like that. Next thing we want to do is take this limit of x squared, break that up a little bit farther. So x squared literally just means x times x. So what we have here is the limit of a function times another function. So again, using the properties of limits, we can break this up as the limit as x approaches -2 of x times the limit as x approaches -2 of x, plus, now we have the limit of 5 times x. So here, 5 is just a constant multiple. So by those properties, we can bring that 5 out in front of that limit notation. And write this as 5 times the limit as x approaches -2 of x. So now the only limit problems we have to worry about are the limit as x approaches -2 of x, limit as x approaches -2 of x, and again, that same limit. So by our properties of limits, if we're taking the limit of a function x by itself, that limit is just -2, whatever value x is approaching. So this is -2, -2, and -2, which means our final answer is going to be -2 times -2 plus 5 times -2. Or -2 times 2 is going to be +4 minus 10 gives us -6 as our final answer. So again, this was a longer way to work out this problem. In general, we won't have to use the properties of limits to break this problem down into so many smaller steps. And we'll demonstrate that as we look at some of these other matched problems.